In this video, I'd like to talk about the math question of the day for March 20th, 2023. And we need to solve this system here using the elimination method. And the elimination method, or solving systems in general, is usually taught in an Algebra 1 class. So at this point, go ahead and pause the video, see if you can work through this on your own, and when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through it. And if you do have suggestions for future questions of the day, feel free to leave those as a comment. Now, we have this system. We have two linear equations. And remember that when solving a system, we are essentially looking at when these two lines, these are linear equations like I mentioned, when these two lines will actually intersect each other. And I won't draw these in exactly, but we will just get some rough idea of what's actually going on here. And with these two lines, we are looking at when they cross each other. And at this point, we don't know where they will, but they will most likely cross each other at some point. Now, there are two exceptions to that. We could have two lines that are parallel to each other, and those lines will never cross each other. So in that case, we would get no solution. Or we could have a third option where our line lies exactly on top of another line. And in that case, they intersect at every single point, and we have infinite solutions. So there are three cases, but the most common is where the two actually intersect each other. So we're looking for this point, and one method we can use is elimination. We could also use other methods. We could graph these, though that tends to be imprecise. We could use what's called the substitution method, where we pick one equation, we solve it for one of the variables, it doesn't matter which, and then once we solve this, let's say for y, then we plug that into our second equation, whatever y is equal to, we'll replace it here. We reduce it to an equation with just x's, which means we can solve it for x. And once we figure out what x is, we just plug it into our first equation here to figure out what y is, and that will give us our coordinate point. So that method is what we call substitution, but elimination can be useful as well. In fact, if these linear equations are written in their standard form, then elimination might be the method of choice. We line up the x's, we line up the y's, and their equalities and what these constants are, and then we just add or subtract the two equations. We might have to multiply the equations so that when we add or subtract them, we actually get a cancellation, but that's the general strategy. And to see that, let's look at a simpler example. Since this one's a little bit more complicated, let's say we have 2x minus y is 4, and we have 2x plus 3y is, let's say, 2. And with the elimination method, notice that the coefficients on x are the same. And if we were to subtract this entire equation from the top one, then the x's cancel out. We get 0x minus y minus 3y. We get minus 4y is equal to 2, and we can solve for y here, since y would just be minus 1/2 in this case. And once we figure out what y is, we just go back to either equation, plug it in, and figure out what x is equal to. But this whole strategy is based on the fact that we can either add or subtract an entire equation to another one. And that's just based on the fact that you can add the same thing to both sides of an equation and it won't change the equation. On the left-hand side, we're adding this 2x plus 3y. And on the right-hand side, we're adding this positive 2. But they are the same thing, since 2x plus 3y is equal to 2. So we're adding the same thing, or subtracting, I should mention, from each side of the equation, so the overall equation doesn't actually change. But we are able to simplify this so that we can isolate one of the variables and then solve for that. So with the elimination method, the goal is to line up these equations so that either the coefficients on x or y are the same in both equations. And with this problem, like I mentioned, it's a little bit trickier than this. We can notice that the coefficients on x are different and the coefficients on y are different. So we first need to manipulate each equation so that we can get either the coefficients on x to be the same or the coefficients on y to be the same. And either way works, but you might have a preference. So let's start by just rewriting these. I'll do it very quickly. And let's say we want to make the coefficients on y the same. And I should mention they don't have to be the same. They could be the same or they could be opposites. We could have 3 and -3. That would be fine as well. So it's really a matter of preference how you want to manipulate these. But let's focus on y because these numbers are smaller and they have a smaller common multiple. Whereas if we use 4 and 3, they have a common multiple of 12. So we would need to multiply the top equation by 3 and the bottom equation by 4 so that each coefficient on x would be 12. But since the y values are smaller, we won't have to multiply by as big of numbers. So for instance, if we multiplied this equation by 2, both sides of the equation, and we multiply both sides of this equation by 3, then the coefficients on y would be 6 and -6. And from there, we could just add the two equations. And we would get 8x plus 6y is equal to -38. And for this bottom equation, we would have 9x minus 6y is equal to -30. And now that we matched up the coefficients on y so that they're opposites, we need to ask the question, should we add or subtract this bottom equation from the top one? And since these are opposites, we should add these because 6 minus 6 is just 0. We would end up with 0y and eliminate this y variable. Now 8x plus 9x, that's 17x. And we do -38 minus 30 or plus -30. That would be -68. So we simplified this. We use the elimination method so that we can get x by itself. So that we have 17x is -68. And if we divide, x would be -4 here. And once we find either x or y, we just plug it into one of these equations so that we can figure out the y value. So let's go back to this bottom equation here and plug in x is -4. And I'm just using this one because the numbers are smaller, but you can certainly use this one as well. And in fact, that's a way to check by plugging it in to the other equation and see if you get the same result. So we plug in x is -4. We have 3 multiplied by -4 minus 2y is -10. Let me make some more room here. And this is -12 minus 2y is -10. We add 12 to both sides. We get 2 on the right-hand side. And dividing by -2, we would get -1. So it looks like the coordinate point at which these two lines intersect each other is -4, -1. So this is what we think is our final answer. But these are fairly straightforward to check. We think the answer is -4, -1. We just plug that into both equations and see if we get back something that makes sense. Here we have -16 and then 3 times -1, that's -3. -16 minus 3 is -19, so it works in the top one. If we plug it into the bottom one, we would get -12 and then -2 times -1, that's +2. -12 plus 2 is -10. So it works in both equations, which means we can feel very confident that this is in fact the correct answer.